Good evening and welcome to another Learning Together session sponsored by the Brosis Foundation. We have been focusing on set theory, and we laid the foundation the last time we were together. We laid the foundation. We defined some key items, including union, intersection, and complement. I'll just do a quick reminder. If we had, say, two sets, A and B, and this is our universal set, and I ask you, what is the intersection of sets A and B? It would be this area. So if there's anything common to A and B, it will be found in that area. Similarly, if I asked you, what are the elements that are in B, but not in A? In B, but not in A. So it's actually B intersect A complement. It's B intersect A complement. In B, but not in A. So here's A. And this is the only thing that is in B, but not in A. Just that section right there. If we're looking for the union of A and B, that's A union B. It's all that is in A combined with all that is in B. So in that case, it would be all of this. That will be the union of A and B. So we could go on and on and on and on, but tonight or today, I would like to look at some examples that we could solve using what we call the Venn diagrams. Okay, so let's get started. I have a few questions. I'll share the questions and then we'll look at the solution. The first one says, a college has 150 freshmen. 150 freshmen. 85 were registered for a math class, 70 were registered for an English class, and 50 were registered for both math and English. Okay, and then there are some questions that follow. So let's write. We have 150 freshmen. 85 for math, 70 for English, and 50 for both. Okay? And the first question that is asked is, how many signed up only for a math class? Only for a math class. So, we know that math is 85, but 50 do math and English. So for those with just math alone, it has to be 85, so let's call this the first one. Math only would have to be equal to 85, take away 50, which of course is 25. Next question asks, how many signed up only for an English class? So what we could do actually, before we even start answering them individually, we could do something like this. So this is your universal set. This is math. This is English. Math has a total of 85. English has a total of 70. And there are 50 here. So we know that for math only, we would have 25. No, not 25, it's actually 35. Now that I can see it, 50 from 85 is 35. And then for English only, 50 from 70 leaves 20. What else do they want from us? How many signed up for math or English? So it's either here, here, or here. So that's going to give you 35 plus 50 is 85, plus 20, 105. So M union E, number of people with math or English will be equal to 105. Okay, and then question, how many signed up for neither math or English? Well, there are a total of 150. And 105 of them have math, English, or both. So therefore, the number that did not sign up for math or English has to be 150, take away 105, which of course is equal to 45. So 45 freshmen did not sign up for math or English. So that's how that question would be addressed. Let's look at another one. Let's look at another one and see if we could solve that also. Okay, so 100 students were interviewed, 28 took PE, 31 took bio, 42 took English, and 9 took PE and bio, 10 took PE and English, 6 took bio and English, 4 took all 3 subjects. And then they ask you, how many students took none of the 3 subjects, etc., etc., etc. So we have 3 subjects that we're working with. So let's try and put it into a Venn diagram. So we have 100 students. We have 28 for PE. We have 31 for bio. We have 42 for English. And we have 9 for PE and bio. Then we have 10 for PE and English. And then we have 6 took bio and English. And then 4 took all 3. Okay, so now they want us to find how many students took none of the 3 subjects. So let's try something. So we have that's our Venn diagram because we have 3 different subjects. We have PE, we have bio, and we have English. And the universal set is 100. So let's go through the math. 28 took PE, so this is 28. 31 took bio. 42 took English. 4 took all 3. So this will be all 3. 4 people are there. Okay? So now you're told that 9 took PE and bio. So PE and bio will be this area. So if this is 9 PE and bio, then there would have to be 5 here. Because 4 plus 5 gives you 9. Then 10 to PE and English. PE and English, total of 10 in that overlap. So if this is 4, this has to be 6. And then Bio and English, 6. Bio and English, this is 6. So therefore, this has to be 2. And then, of course, if the whole circle is 42, and this is 12, then this has to be 30. If bio is 31, and this is 11, then this has to be 20. And here, PE is 28, this is 15, so this has to be 13. So that's what we have to break it out. And the key to helping us to solve this puzzle is based on the information that is provided, because each section has its own significance. So therefore, what you have to do is, you have to do it systematically, step by step by step by step. Break it down and fill in the pieces, and they will all come together nicely. So where are we now? The question that is asked is, how many students took none of the 3 subjects? So when you find the total of all that's here, it will tell you how many of them took PE, Bio, or English, or a combination of the 3. Okay? So if you're looking for the students who did not take even one of them, whatever total we get for the union of PE, Bio, and English, we subtract it from 100, and that will be the number of students who took none of those subjects. So the quickest way to do this is 42. And the only thing that's left is this, and this. So let's go. 5 and 13 is 18, and 20 is 38. And this is 42. So therefore, we have 80 people who took 1, 2, or 3 of these subjects. 1, 2, or 3. Okay? The total came up to 42, 25, 38, 80. So therefore, the answer to the first question, how many students took none of the 3 subjects, would be 100, take away 80, equal to 20. How many students took PE, but not Bio or English? PE, but not Bio or English. So here's PE. These are the students who took PE, but the ones that didn't take Bio or English would have to be 13. This is the number we need. 13 will be the answer to that question. And finally, how many students took Bio and PE, but not English? Bio and PE, but not English. So therefore, 4 from 9, 5 is the answer to that question. Because these people just took 2 subjects only, Bio and PE. And that's how we would solve that question. So again, these questions look tricky, but then once you start to break it down systematically, just take it step by step, it comes together nicely. So here's another question. I'll put it on the board so that we can look at it together. Okay, here we go. So this one, at a breakfast buffet, 93 people chose coffee. Coffee, 93. 47 people chose juice. Juice, 47. And 25 people chose both coffee and juice. Both C and J, we had 25. Let me read it again. At a breakfast buffet, 93 people chose coffee and 47 people chose juice. 25 people chose both coffee and juice. If each person chose at least one of these beverages, how many people visited the buffet? So here we go. It says here that if each person chose at least one of these, either coffee, juice, or both, how many people altogether participated in the buffet? How many people visited the buffet? All right, let's fill in the pieces. 25 took both. This is coffee. This is juice. So we're saying 25 took both. So therefore, how many took juice alone? The answer would have to be 22. Because 25 plus 22 gives us 47. Is either you took coffee alone, or you took, juice alone, or you had juice and coffee, where the two overlap. Okay? Here, it says 93 people took coffee, and 25 of them took coffee and juice. So those who took coffee only would have to be 93 take away 25, which gives me 8 and 6. Okay? So they said each person will be found in either here, here, or here. They all took a form of liquid, a form of beverage, whether it's coffee or juice or both. So the total that came to the buffet would be 68 plus 25 plus 22. 68 plus 25 plus 22, which of course is equal to 80 plus 25 equal to 100. 105. Again, just looking at these numbers like that might not be as easy to understand how to get the answer. But once you put it together in this format, it becomes easier to see. Okay? Okay, let's try and do another one. Let's do one for all the juice and for all the fruit lovers. Here we go. A group of 62 students were surveyed, and it was found that each of the students surveyed liked at least one of the following 3 fruits: apricots, bananas, and cantaloupes. So let's go. Total. So we have a total of 62 students. 34 for apricot, 30 for banana, and 33 for cantaloupe. Okay, what else do we have? 11 liked apricots and bananas. So A and B, 11. 15 like bananas and cantaloupe. B and C, 15. 17 like apricots and cantaloupes. A and C equal to 17. 19 liked exactly 2 of the following fruits: apricots, bananas, and cantaloupe. So 19 this is very critical. 19 liked exactly 2, not 3, just 2. Okay, here we go. How many students liked apricots but not bananas or cantaloupes? So what I recommend is represent these pieces of information in a Venn diagram. And by the way, we know Venn diagram is spelled V-E-N-N. Oops. That's a Venn diagram, okay? So we're doing 3 circles. And since it says that every student liked at least 1, so there is no student that is outside of all 3 circles. They must be found somewhere within one of the circles. Okay? So we have apricot, banana, and cantaloupe. So for apricot, we had 34 total. For banana, we had 30 total. And for cantaloupe, we had 33. What do we know? It says that apricot and banana is 11. Apricot and banana is 11. So there are 11 people in this group who like both apricot and banana. It didn't say apricot and banana only. It just say that they happen to like banana and they also like apricot. It doesn't say what else they might like, but you know it, they cover those 2 areas. What we do not know is how many students liked all 3 fruits. Since we do not know that number, we could call that number X. We don't know what's here, but we know that apricots and bananas gives us a total of 11. So this has to be 11 minus X. Then apricot and, so banana and cantaloupe is 15. Banana and cantaloupe is 15, so this is 15 minus X. And then apricot and cantaloupe is 17, so 17 minus X. And they tell you that 19 like exactly 2 fruits. So what area deals with only 2 fruits? Only 2 fruits. 19 like exactly 2. So this area right here represents apricot and bananas only. It does not cover, it does not overlap with cantaloupes. This one right here is cantaloupe and banana only. It does not overlap with apricot. And this one here goes with apricot and cantaloupe, but no banana. Okay? This plus this plus this is exactly 19. So that's our key to start breaking this thing down. So let's see if we could find what X is. So we will have 11 minus X plus 15 minus X plus 17 is going to be equal to 19. These 3 areas represent 2 fruits only, not 3, not 1, 2 fruits only. When we do the addition, we have 11 plus 15 is 26. 26 plus 17 is 43. minus x minus x minus x minus 3x equal to 19. Okay, what am I going to do? I'm going to add 3x to both sides and subtract 19 from both sides. Or, let's keep it simple then, okay? Subtract 43 from both sides. You don't like that? Okay, all right, so let's add. 43 equal to 19 plus 3x. Feel better? Then subtract 19. This gives me 4, this gives me 24, equal to 3x. So therefore we see x is equal to 8. So we now discover that 8 people liked all 3 fruits. So this now becomes 8 in the center. Of course, if this is 8, then this is going to be 7, this is going to be 3, and this is going to be 9. Okay? So the first question they asked us is, how many students like apricots, but not bananas or cantaloupes? So apricot, but not bananas or cantaloupes. So none of, so they would have to be just in this group right here. So, we know this is 8. So therefore, this is going to be 11 take away x is going to be 3. This take away 8 is going to be 9. So 9 plus 8 is 17, plus 3 is 20. 20 from 34 leaves 14. So the answer to that question is 14. If you were to try to solve this without the diagram, it would be a very difficult task. But of course, using the picture, using the Venn diagram, it's very easy to discern what should be done. So hint, use the Venn diagram where possible. Next question is, how many students like cantaloupes, but not bananas or apricots? So again, total of 33, and we know that 8 from this leaves 7. And then this is 9 right here. Okay, so now we go, it's gonna be 8 plus 9 is 17, plus 7 is 24. 24 from 33 leaves 9. So the answer, how many students like cantaloupe but not bananas or apricots? The answer is 9. Then the next question is, how many students liked all of the following 3 fruits, apricots, bananas, and cantaloupes? We already solved the problem, we got 8. And finally, how many students liked apricots and cantaloupes, but not bananas? Apricots, cantaloupes, but not bananas. So it's this area right here. So if this is 8, this has to be 9. That one was quite a bit tricky, isn't it? Okay? Okay. So let's do another one, still dealing with food. Let's do another one. This time we're going to go with fast foods. Okay, we got a piece of paper. And if you notice, I'm taking my time because this is a different kind of math. This is called set theory. Okay, let me read the question and then we'll start to analyze it. 90 students went to a school carnival. 3 had a hamburger, soft drink, and ice cream. 24 had hamburgers, 5 had a hamburger and a soft drink. 33 had soft drinks. 10 had a soft drink and ice cream. 38 had ice cream. 8 had hamburger and ice cream. How many had nothing? So just by reading it, it becomes so confusing. it's so confusing because there's like, whoa, how many fingers do I have to put here and put here? No, it's not gonna work. We need a picture so we can see clearly. So let me try one more time. 90 students went to a school carnival. What they're suggesting is that some of the students had something, but there are some students who had nothing. That's the number that we want to find. So what are the clues? 3 had a hamburger, soft drink, and ice cream. So 3 people had all 3 items. 24 had hamburgers. 5 had a hamburger and a soft drink. 33 had soft drinks. 10 had a soft drink and ice cream. 38 had ice cream. 8 had a hamburger and ice cream. How many had nothing? So I suggest that we draw a Venn diagram involving 3 circles. 1 for hamburger, 1 for ice cream, and 1 for soda, soft drink. Okay. Oh, I should write it up, total. So 90 students. So we have hamburger, soft drink, and ice cream. And that gives me a total of 3. Then we have soft drink. Okay, so 24 had hamburgers each. 5 had a hamburger and soft drink. So hamburger and soft drink, 5. 33 had soft drink. S. 10 had a soft drink and ice cream. S-I. 38 had ice cream, so I. 8 had a hamburger and ice cream, so H. I is 8. And what they want is how many had nothing. Okay, so let's go. So our universal set has a total of 90. Total of 90. So let's use this as hamburger, this as soft drink, this as ice cream. According to the information, ice cream, soda, and hamburger, soda, and ice cream is 3. Hamburger is 24. So I'm putting in the information sequentially, step by step. Hamburger and soda is 5. Hamburger and soda. So those who have hamburger and soda is 5. So if this is 5 and this is 3, then this has to be 2. Soda is 33. Soda and ice cream is 10. If this is 3, and this has to be 7. Ice cream is 38. Ice cream and, what's that? Hamburger and ice cream is 8. This has to be 5. Okay? So now we're ready to rock and roll. If this is 24, the whole thing is 24, and this is 10, this has to be 14. If the whole thing is 33, and this is 12, then this has to be 21. The whole thing is 38, and this is 15, and this has to be 23. So when they ask you how many students had none, so we're looking for what is outside here, call this X. So the student is neither here, 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 here. They're outside of the 3 circles. So they had neither hamburger, ice cream, or soda. So now we need to total these areas and then subtract that from 90, and boom, there it is. So let's go with this. Let's start with the 38. This is 38. So these 4 make up 38. So all we need to do is to add this, this, and this. So it's 38 plus 135 and 510. Sorry, 38. This is 16, 14 and 2, 16, and 21 is 37. Let me double check. This is 38. All 4 make 38. So this is going to be 40. Sorry, this is 21, 23, and 14, 37. So that gives me a total of 75. So 75 had at least one of the 3 items out of a total of 90. So therefore 90 minus 75 equal to 15 did not have any of the 3 items, 15. Okay, pretty good so far. Let's look at another question. Okay, let me make some space. So the big takeaway is that set theory is just supposed to be another tool in helping us to problem solve. That's what set theory does. It's another tool that will help us to problem solve. Okay, here goes. In a group of 60 people, so we have group or total equal to 60 people. 27 like cold drinks and 42 like hot drinks. Cold, 27. Hot, I think it says 42 for hot. So all I'm doing is just extracting key information. In a group of 60 people, 27 like cold drinks and 42 like hot drinks. And each person likes at least one of the 2 drinks. So each person must be either here, here, or where the 2 overlap. Likes at least one of the 2 drinks. How many like both coffee and tea? How many like both coffee and tea? So again, you go zoom, zoom. Cold is 27. How many like, is it coffee and tea? That's what it says? Wow. Okay, so that is that. This is hot, which is 42. I think what they should have said was how many like both hot or cold? How many like both hot or cold? That's what they should have asked, but hey. So it says, this we don't know. This is the number we want. We don't know how many liked both, but we know that 27 liked coffee So therefore, this has to be 27, sorry, 27 like cold. So this has to be 27 minus x. Total of 42, so this has to be 42 minus x. And these three areas must give us a total of 60. Put the three areas together and you should get a total of 60. So here we go. 27 minus x plus 42 minus x is equal to 60. This area is cold only, this area is hot only, this area is hot and cold. And we were told that every student liked at least the hot or the cold, at least the hot or the cold. They could like both. Okay? How does it simplify? 27 plus 42 gives me 69. Negative x plus x is 0. Minus x equal to 60. Of course, we look at it and say 69, take away what leaves 60, you realize that x has to be 9. So 9 people liked both the hot and the cold. Let's see another one. Okay, here goes. There are 35 students in art class and 57 students in dance class. Find the number of students who are either in art class or in dance class. Okay, let's go one more time. There are 35 students in art class and 57 students in dance class. Find the number of students who are either in art class or in dance class. So let's go. Art is 35. Dance is 57. And of course, we should have students who have both art and dance. So this is A 35, D 57. What do they want from us? They say, okay, find the number of students who are either in art class or in dance class. So we need this plus that. When two classes meet at different hours and 12 students are enrolled in both activities. Oh, so this is 12. So that becomes easy now. That's 12. So this has to be 23. And this has to be now 45. That's it. Find the number of students who are either in art class or in dance class. So it's going to be this, or that. So our total is going to be 23. Well, this is 57. 57 plus 23, and that gives me 80. So we have 23 students extra. Okay, there it is. The answer is okay. And then the next question says, when two classes meet at the same hour. When two classes meet at the same hour. Okay. Okay, so when two classes meet at the same hour, that doesn't make any form of sense. Okay. When two classes meet at the same hour, two classes meet at the same hour. So if the two classes meet at the same hour, you can't be in both classes. You can't. So we're gonna have, okay. So this is A 35 and D 57. Okay. So two classes meet at the same hour. So the first one is when two classes meet at different hours. Okay. Two classes meet at the same hour. That doesn't add up. Okay. I'm going to skip that because it doesn't make sense. Okay. Let's try this other one. In a group of 100 persons, 72 can speak English and 43 can speak French. How many can speak English only? How many can speak French only? And how many can speak both English and French? Okay, so this is the last one we're going to do in this section. And then I'm going to look at one other type of question before we close. Here we go. Okay. Total 100 people. English, we have 72. For French, we have 43. And of course, there will be some that speak both French and English. Let's see if they give us any qualifier. In a group of 100 persons, 72 people can speak English and 43 can speak French. How many can speak English only? How many can speak French only? And how many can speak both English and French? So, this is English and French, and if this is 72, then this has to be 72 minus x. This has to be 43 minus x. And they ask the question, okay? And of course, the total is going to be 100. Okay? So here we go. Okay. Let able to set da. Okay. Okay, and say, how many can speak English only? So English only is going to be this. So we know that 72 minus x plus 43 plus 43 is equal to 100. So now we end up with 72 let's add these together. 3 and 2 is 5. 4 and 7 is 11 minus x equal to 100. So therefore, x has to be equal to 15. The question they asked us was, how many can speak English only? So English only is going to be 72, take away 15, and that gives us 57. Okay, so that's equal to 57. English only. How many can speak French only? So it's 43 minus 15 gives us 28. And how many can speak both English and French? The answer is 15. Again, if we left the question strictly in words, it would have been much harder to solve, okay? I just want to finish up with a couple diagrams and also interpretation of the information. So please note, if you're having difficulty with this session, you must look at the one before this that covers the introduction to set theory. because without the introduction, then this is going to be foreign. So make sure you look at the introduction before you try and jump into this. Okay? So here we go. Let's deal with something that is pretty neat. Here we go. This is swimming. This is rugby. This is 5, 15, 6, this is 4. And the first question says, how many students only like rugby? Only like rugby. So these students like rugby, but these 15 also overlap with swimming. So the answer to the question, how many only like rugby? Oh, I have the numbers switched around here. So swimming is over here. Yes. So the answer to how many only like rugby is going to be 5. How many students do not like rugby and swimming? You do not like rugby and swimming. Okay. So rugby. How many students do not like both rugby and swimming? So these like rugby and swimming. So these like rugby only, these like swimming only, these like neither. So these 3 areas would answer the question. 6 plus 5 is 11 plus 4 is 15. Again, the question says, how many students do not like both rugby and swimming? So they like both rugby and swimming. So everything else would fall into the category that we're looking for. They do not like both rugby and swimming. Rugby and swimming here, so everything else would fall into that space. How many students do not like rugby? Well, do not like rugby. So 20 like rugby. Okay, so 20 like rugby. How many do not like rugby? Would have to be 6 plus 4 gives you 10. The answer will be 10 for that. How many students do not like swimming? Well, this is swimming. 21 like swimming. These do not like swimming, they like rugby only. And these are losers, they don't like rugby or swimming. So 4 and 5 would be 9. Okay? How many students like rugby or swimming? Rugby or swimming. So they're going to be in one of these areas right here. How many will that be? That's 20 and 6, 26. How many students like both rugby and swimming? You see, both will be the intersection where the 2 overlap. That's 15. How many students like swimming? This is swimming. This person, these like swimming, total of 21. How many students do not like either rugby or swimming? They do not like either sports. The answer is 4. Okay? And then, how many students only like swimming? Only swimming. That would have to be these people right here, swimming only. Okay? And finally, how many students like rugby? Rugby, these 2 sections, 15 plus 5 gives you 20. Okay? And I'll do my last question, and that's it. Last question. tennis, badminton, and swimming. Okay, and this is 7. From this Venn diagram, the question is asked, how many students do not like either tennis or badminton? And this is tennis, this is badminton, so they cannot be in either of these, in any of these 1, 2, 3, 4, 5, 6 areas. So it have to be 17 and 15 gives us 32. How many students like badminton or swimming? So badminton is here, swimming is here. There's going to be all of this plus these 2. So we just need to total these numbers here. So what do we have? This is 30, 47, 54, 59, 69, 978. Okay. How many students like both tennis and badminton but not swimming? Tennis and badminton but not swimming. So this area is all 3, so the answer is 19. How many students like both tennis and swimming? Tennis, swimming. So it's these 2, sorry, how many students like both tennis and swimming? Tennis and swimming, both tennis and swimming is this area. 12 and 18 is 30. How many students like tennis or badminton? Tennis or badminton. So it has to be 1, 2, 3, 4, 5, 6. We have to total these 6 areas. Okay, this is 30 and 20, 50, 69, 74. And then how many students only like tennis? Only tennis, 13. How many students do not like both tennis and badminton? Do not like both tennis and badminton. So these tennis and badminton, we have a total of 37. So therefore, those who do not like both tennis and badminton would have to be this, and this, along with this. So this is what, 25, 40, 40, 45, 52, 62, 69. 69. Then how many students do not like both tennis and swimming? Do not like both tennis and swimming. So tennis and swimming here is here. Do not like both tennis and swimming. So so we have to add this, and this. So let's go. 7 and 17 is 24, 29, 39, 42, 52, 57. And then finally, how many students like both badminton and swimming but not tennis? Both badminton and swimming but not tennis. So both badminton and swimming but not tennis would be just this area right here, 7. Badminton and swimming but not tennis, so 7. So again, really a little fun tool that is extremely useful. I certainly hope that you saw how set theory can be used to solve questions that come in the form of puzzles, overlap, union, complements, and what have you. On behalf of the Brosis Foundation, I just want to express thank you for sharing this time with us. We truly appreciate your time, and we hope that something was said or shown in this video that has become more helpful to you as you understand the application of set theory in problem solving. Thank you so much for joining us, and we hope you'll come back and join us again for another wonderful session of learning together, sponsored by the Brosis Foundation. Enjoy the rest of your day.